All right. Hi, hello, good afternoon, my dear students. How are you all? I hope that everybody is in the best of their health. And I, Ritika, your chemistry educator, am here at Unacademy's YouTube session, bringing with me some of the very important topics of your term 2 examinations. So as you already might be knowing, what are we going to learn today? We are going to have a session on the important questions of your important chapter, metallurgy. So today basically we are going to have a quick short revision on metallurgy, and of course we are going to see some of the important questions that might be present in your examinations. Okay, so let's quickly start. Before that, let's know a bit about me. So I'm Ritika, your chemistry educator. I have completed my engineering in electronics and communication, and right now I'm here teaching you all chemistry. Students, if you need any assistance in the homework or your class notes, you can join my Telegram channel. The link is provided to you in the description box of this video. Also, you can follow the official Telegram channel of Unacademy ICSE board so that you do not miss out any session. Okay, you stay updated with all the ongoing offers and all the amazing things over here. So let's quickly get started now. Okay, perfect. Okay, now we will be just having a quick short revision of this topic, metallurgy, and then we will be solving some of the questions related to this unit. Okay, so basically see, if I talk about elements, we classify them into the three categories of metals, non-metals and metalloids, right? If I talk about metals, what are metals? These are the, hello Rohit, metals are the elements having 1, 2 or 3 electrons in the valence shell, and because of 1, 2 or 3 electrons being present in the valence shell, they easily donate their electrons and they have got the electropositive nature, right? Some of the properties of metals are ductility, means that it can be drawn into wires. Then its malleability. So malleability basically means that it could be converted into thin sheets. Then generally the metals are lustrous. Of course there are some exceptions. So lustrous means they have got a shine. Then they are good conductors of heat and electricity. They are electron donors. Okay, and they form positively charged ions. Hello Shristi, they form the positively charged ions which are known as cations. Okay, so these are some of the general properties of metals that you should be knowing. How are they electron donors? I guess everybody might be knowing, right? If I talk about aluminium, the configuration of aluminium is 2, 8 and 3, atomic number being 13. Okay, yeah, of course I remember you. So welcome back to the session. Alright, talking about aluminium, see, it has got 3 electrons in the outermost shell. So what is the usual thing that aluminium does? It gives out the 3 electron. Rather than taking 5, it better gives out 3. So when it gives out 3 electrons, it gets a positive charge, and these are known as cations. Okay, similarly sodium, magnesium or potassium, they all form the positive ions. Okay, next if I talk about some of the noble metals like gold or copper or platinum, they are normally found in the free state, okay, because they are not very reactive. Okay, alright, then talking about some of the elements which are having 5, 6 or 7 electrons, they are non-metals. Okay, so they actually are not metals, and they show the properties related to non-metals. Okay, now if I talk about the properties of the metals. Okay, so the very first is they donate the electrons. Okay, so they are electropositive in nature. Next is talking about their reaction. So when they react with air, for example, if I go for lithium, if I go for sodium, potassium, etc., they react with air, okay, and they form their oxide. Talking about the reaction with water, so the alkali metals, they react with water, okay, to form their soluble bases, okay, that is alkali. Okay, all right, moving on to the next thing. Okay, so after that we already discussed that they are highly electropositive in the nature, okay, and they are showing different properties related to the positive nature. Okay, now we will be moving on to metallurgy. So basically what is metallurgy? It is related, or it actually involves everything to take out the metal from the earth and to have the finished product. Okay, if I talk about metals that we are using, we do not get it in the finished state. Okay, so they are present in the earth's crust in the form of their oxide or in the form of their carbonate, etc., etc. So there has to be a particular process that we need to follow up to get the metal in the pure state, and this all things are coming under the metallurgy. Okay, so if I talk about minerals, these are the naturally occurring compounds of any metal. So we can say the minerals are naturally occurring compounds of metal. Okay, now see, from every mineral we cannot get the metal profitably. So for that we are having ores. So what are ores? Ores are basically minerals from which we can get the metal at two conditions. First is low cost, and second is we can get it conveniently. Okay, so ores basically are the minerals from which we can get the metals at low cost and the conveniently. Now of course with ores there are some of the impurities associated, right? So these impurities are known as gangue or matrix. Okay, so how to define it? The impurities which are associated with ores, they are known as gangue or matrix. Okay, next talking about metallurgy. What is it? It is the process of extracting the metals from their ores by various methods, by various physical or various chemical methods. So it's basically the process of extracting metals from the ores. Correct? Alright. These are the things. Now students, a very important information about this chapter, metallurgy. See, I guess the processes involved in metallurgy, they are not involved or they are not included in your syllabus for now. So we will just have a basic description about the process that go on, but we won't be going in detail because these are reduced from your syllabus. Okay, so metallurgy, it is not one step process. There are certain steps that we need to follow to get the metal in the pure form. So basically first we have ore, then it goes for dressing. Okay, so in the dressing the pulverization happens. The ore, it is crushed into fine powder. Okay, just a minute. Okay, after that what happens is concentration of ore. After concentration, the ore goes for roasting or calcination process. Okay, then it goes for reduction. At the last it goes for refining, and we get the metal in our head. Okay, so these are the various methods that are that any ore is undergoing to have the pure metal in the hand. Okay, so as I already told you that these things are not present in your syllabus for now, so we won't be going into much detail sorry into it. Okay, now then we are having very important topic. It is the extraction of aluminium. Okay, so please remember this is one of the very important topic. Now the main ore from which aluminium is extracted, it is bauxite. The formula is Al2O3.2H2O. Okay, now if I talk about the purification of ore, it is done by Bayer's process. Okay, and then we also have learnt about Hall-Herold's process. Okay, so these are the two steps that we of course will be discussing when we will be going for the question. Okay, so these are the two steps. Please try to remember the steps of these processes since they are very important from your examination point of view. Okay, so let's just discuss the processes once. Okay. Okay, so what is happening in the Bayer's process? Basically, we are purifying the ore. Okay, and similarly in Hall-Herold's process also we are going for the same. So you could be asked over here some of the direct questions that, okay, explain the steps going in Hall-Herold's process, or explain the steps of Bayer's process, or what are the reactions happening at cathode, what are the reactions happening at anode. Okay, these are the things that you could be asked. So kindly be careful and just go through the topics once. Okay, all right, moving further, let's go for the questions. But before that, let me tell you a bit about the Unacademy's free live classes. So these special classes, these are absolutely free of cost. Okay, so everybody can watch it. Okay, just you need to have the Unacademy Learner app. So in these classes, you can have a real-time interaction using the chats and emojis. You can talk to your educators. You can ask the question using the question tab. So here you can either type your question, you can attach the image of your question. Also we are having the live poll options. Okay, polls are the questions that educators ask you, and you can answer them, and you can have a competition among your friends or among whoever is present in the class. Okay, we also have leaderboard options. Okay, so this is our special class timetable, students. We are going to meet today at 4 p.m. to have a one-shot revision on nitric acid. Then on 24th of February, we are going to have a poll war on nitric acid, basically question answer session. And on 26th February, 4 p.m. we are going to have a poll war on sulfuric acid. So these are the important sessions that we are going to have. Kindly make sure that you attend these sessions. Talking about the Unacademy subscription features, so there are certain features which you get when you apply or when you go for plus subscription, such as you can learn from the comfort of your home, you get unlimited access to all the courses, you are taught by the top educators of India at one platform. Apart from regular classes, we also have doubt clearing session and answer writing session. Then you are under the mentorship and guidance of your tutors, and you get all the study material in the PDF format. Okay, so to avail all these things, kindly go for plus subscription. Talking about the pricing plans, these are the plans available at various durations, so you can go for any duration you're comfortable with, 3 month, 4 month, 18 month, 24, 48, anything. You can use my code RITIKACLIVE to avail extra 10% discount. Okay, so now we will be moving on to the questions. Okay, so the very first question is differentiate between differentiate between metals and non-metals. So we will keep one column for metals and other for non-metals. Okay, so the very first difference that we can have for metal, they are having 1, 2 or 3 electron in their valence shell. Correct? And about non-metals, they generally have 5, 6 or 7 electrons in valence shell. Okay. Now, in the case of metals, they readily lose the valence electron. So, they lose valence electron, and since they are losing, so they form cation. Correct? And non-metals, they gain valence electron readily. So, they gain valence electron and they form anion. So, in the case of sodium, let's say sodium, it gives its 1 electron to form a cation. In the case of fluorine, it gains 1 electron to form anion. Okay, this is the case. Okay, now if we go for electrolysis process, metals will be always obtained at cathode. Okay, we are getting metals at cathode and we are getting non-metals at anode. Okay, then talking about some of the next properties. So metals, they generally are the reducing agents. They are electron donors, so they act as reducing agents. And non-metals, they are oxidizing agents. Correct. Talking about some of their physical properties. Okay, so generally the metals are solids. Okay, some of the exceptions are of course there. For example, mercury, which is liquid. Okay, and non-metals, they generally are gases. The exception is bromine, which is liquid. Okay, non-metal. Then metals have got high density and non-metals generally they have low density. But over here, a diamond, it is the hardest substance known and it has got a high density. Okay, then talking about their melting point, so they have got high melting point and boiling point, and non-metals, they have got low melting point and boiling point. Okay, now over here everything, it has got some or the other exception. Okay, so please try to remember the exceptions. Okay, if I go for the properties of metals, they are malleable and ductile, but that property is generally not seen in the case of non-metals. Okay, now please remember the differences. Okay, you could be asked, list any 2 differences between metals and non-metals, list any 2 chemical differences between metals and non-metals. So you should be really thorough with the answers. I'm sorry. Okay, so I hope that these questions are very much clear to you. Okay, let's quickly see what are the differences that we saw. So metals having 1, 2 or 3 electron in valence shell, non-metals having 5, 6 or 7. Metals, they lose electron and form cation, non-metals gain electron to form anion. Then metals are obtained at the cathode during electrolysis process and non-metals are obtained at anode. Metals are good reducing agents, non-metals are oxidizing agents. Metals generally are solid, exceptions are there such as mercury. Non-metals are generally gases. And then metals have high density, high melting boiling point, and non-metals, they have low density and low melting boiling point. Okay, and please remember the exceptions. Okay, now define the following terms. The very first is metallurgy. Okay, so we will begin with the first one. What is basically metallurgy? See, it is the process in which the ore, it is undergoing through various process to extract the metal out of it. Okay, so basically metallurgy is process of extraction of pure metal from their respective ores. Okay, so the process of extracting the pure metal out of the ores, it is known as metallurgy. Next is mineral. So what is a mineral, or how to define mineral? It is, minerals are the naturally occurring compounds of metal. Okay, they are present in the earth's crust and they are the naturally occurring compounds of metal. After that we have ore. Okay, so basically ore is a mineral only, okay, but it's a mineral from which we can extract metal. So minerals from which metal can be extracted. Now over here there will be two things that we need to remember: extracted at low cost and low cost and conveniently. So there are these two things. Okay, so ore, it is basically mineral. So we can say all ores, they originally are minerals, but all the minerals, it is not sure that they will be ore. Okay, because some minerals, they are having the metal content very low, so they cannot be giving us the ore profitably. And then it is matrix. So what is matrix? See, if I go for mineral or ore, they always have some of the impurities associated with it. Okay, so the matrix, or it is also known as gangue. Okay, so it is the impurities associated with ore. Okay, so these are the basic definitions, okay, about mineral, ore, matrix and metallurgy that you should be thorough with. Alright, next is give a brief account on the steps carried out in the Bayer's process. Okay, so first of all we should be knowing what is Bayer's process used for. Okay, so Bayer's process, it is the process of concentration of bauxite ore. Okay, so with this we are going for concentration of bauxite ore. Okay, now this process, it is basically a three-step process. Okay, now in the very first step, what is happening? The impure bauxite, it is converted to sodium meta-aluminate. Okay, so conversion of bauxite to sodium meta-aluminate. Okay, now how is it happening? See, we take the bauxite, that is Al2O3.2H2. Okay, and we mix, or we mix it with the concentrated solution of sodium hydroxide. The temperature that we provide over here, it is approximately 200 degrees Celsius. And what do we get? We get sodium meta-aluminate. And as I always say, kindly write the name of the products that we get. So here we have got sodium meta-aluminate. This is our first step. Okay, now this sodium meta-aluminate which we have got, it is converted to aluminium hydroxide. Okay, so this step second, it is sodium meta-aluminate, it is converted to the precipitate of aluminium hydroxide. Okay, so what are we doing? Basically we are dissolving it. Okay, so we have taken this sodium metaluminate. Okay, we are taking water and the temperature it is maintained at 50 degrees Celsius. Okay, so now what we will be getting? We will be getting sodium hydroxide plus aluminium hydroxide. Okay, now this is our main product, so just write the name. And you can give the symbol to denote that it is a precipitate. Okay, now this precipitate, it is collected, it is dried, washed and filtered, and then it is heated, and the temperature it is kept at approximately 1000 degrees Celsius, and we get the pure alumina from it. So what is basically happening over here? This aluminium hydroxide, it is converted to alumina. And how is it happening? We are igniting it at 1000 degrees Celsius. Okay, so we get over here the product alumina. Okay, and that is what we need. So basically it is a 3-step process. Just remember what are we doing in the processes. First we are converting the bauxite into sodium metaluminate. Then we are converting the sodium metaluminate to aluminium hydroxide's precipitate, and at the last this precipitate it is heated, ignited to have the pure alumina out of it. Hope that is clear. Okay, so students, talking about a very important and a very amazing offer at Unacademy for your Plus subscription. So if you are taking the Plus subscription for grade 9 and 10 or 11 and 12, of course, you are going to get the 2-month extension absolutely free of cost. Okay, so if you are buying the Plus subscription for 12 months or above, you will be getting a free 2-month extension. Okay, so this offer it is valid for first 500 subscribers. Kindly go subscribe to the Plus and have this offer. Also, you can get 10% discount on purchasing the Plus subscription for any duration by using my code. Okay, now next thing is the name the process of extraction of aluminium from alumina. So these are all the questions related to extraction of alumina. Let us solve them one by one. So the process of extraction of aluminium from alumina, it is Hall-Heroult process. Kindly remember in detail what happens in Hall-Heroult process, because it is important from your examination point of view. Okay, second question is, why is electrolytic reduction done to obtain aluminium? Okay, so if I talk about aluminium, it is a kind of reactive metal. Okay, so it is reactive metal. Okay, and it forms strong oxides. So the oxides of aluminium, they are strong, okay, and they cannot be easily reduced to metals. Okay, so therefore we go for electrolytic reduction. So the basic reason that we will be going with is aluminium, it is a very reactive metal, and therefore it forms strong oxides which cannot easily be reduced by to the metal, and therefore we go for the process of electrolytic reduction. Alright, next, what is the composition of the electrolyte? So in the electrolyte we are taking 3 things. Let me note it over here. Okay, so we take fused alumina, then we take cryolite, and we take fluorspar. Okay, and the ratio is 1:3:1. Okay, so what are the components? Fused alumina, cryolite and fluorspar. Okay, please remember the compositions. Next is, what is the function of cryolite and fluorspar? So basically, just let me note it down here. Okay, cryolite and fluorspar, they are acting as, if I talk about cryolite, they act as solvent for the alumina. Okay, so they act as solvent for fused alumina. Next use of them is, they are used to reduce or lower the fusion temperature. Okay, so they also lower the melting point of the mixture that we have taken. So what are the two uses? First, it is used as a solvent, and second, it is used to lower the melting point or fusion temperature. Correct? Okay. Next question was, give the reactions taking place. Okay. So the reactions taking place at cathode and anode, we will be discussing that. So as we have already discussed, at cathode we will be getting the metal. So what happens at cathode? We get aluminium, and at anode we get oxygen. Okay, so we are getting oxygen at anode and aluminium at cathode. Okay, next question is, explain the significance of the following in extraction of aluminium. Okay, so we have been given certain things and we have been asked that what is it used for. So the very first, if I talk about bauxite, it's the main thing, right? It is the chief, or I would say main ore of aluminium. Okay, the aluminium, the bauxite, it contains the Al2,3 up to 60%. Okay, and the other things which are present over here are the impurities. They can be sand, dust, some of the oxides. Okay, so bauxite, it is used for the extraction of aluminium because it has got a good amount of aluminium content. Sodium hydroxide. Okay, so let's go for B. So we just now saw that firstly it is converted to sodium metaluminate. And how is it converted? Because, or by dissolving it in the sodium hydroxide. So this bauxite, it is dissolved in sodium hydroxide. And what do we get by it? We get sodium metaluminate. Okay, and over here points to remember, some of the insoluble impurities are left behind. Okay, so the basic use of sodium hydroxide, it is to dissolve the bauxite, okay, to form sodium metaluminate, and all insoluble impurities, they are left behind. Next is cryolite. So cryolite, as we already discussed, it is used to lower the fusion temperature. The very first use. And second is, it enhances the conductivity. Okay, for the reactions to take place. So the two uses are lower the fusion temperature and enhances the conductivity. Okay, next was graphite. Okay, so we have graphite rods that are used as the anode. Okay, so it is used as anode, in which in the electrolytic reduction. So these are the uses. Correct? Hope that the uses are pretty much clear. Moving on to next question, give the reasons for alloying. Okay, so basically there are certain reasons, okay, that we have, or we go for alloying. First reason can be to increase hardness. Okay, so for example, if I need a particular substance which is very hard, so I may mix two metals or metal and non-metal. Okay, if I go for brass, okay, it is the alloy of copper and zinc. So what is it? It is harder than copper, it is harder than zinc. Okay, next if I talk about duralumin, so it is one of alloy of aluminium. It has got the strength up to 6 times greater than the aluminium. Okay, so the first reason is it can be used to increase the hardness. Okay, next is to change or to modify reactivity. Okay, so for example, if I talk about sodium amalgam, that is sodium plus mercury. Okay, we all know that sodium, it is a very reactive metal. Okay, so what do? We add sodium amalgam. Okay, so it just lowers the reactivity. Okay, so for reducing the reactivity of sodium, we mix it with mercury, which makes it sodium amalgam. So what we have done, we have modified the reactivity. Correct? Next thing is to modify appearance. Okay, talking about the appearance, if I talk about aluminium bronze, which is made up of aluminium and copper, okay, it is known as aluminium bronze. So it looks like gold. Okay, it's bright yellow in color, it looks like gold. So what is happening? The appearance has been changed. Okay, next is we can use to lower the melting point. I'm very sure you might have heard about solder. Okay, so it is the alloy. Okay, and its melting point, it is lower than the lead or tin separately. Okay, so basically it has been used to lower the melting point. Okay, and next is to increase resistance. So nichrome wire, okay, which is the alloy of nickel, ferrous and chromium. Okay, so it has got high resistance. Okay, so basically what are we using alloys for? To increase hardness, or to change the reactivity, or to change the appearance, or to lower the melting point, or to increase the resistance. Okay, so these are all the basic uses that we go for alloying. Okay, next question is, okay, before next question, let me tell you about one information, that is the important questions for your final exams. We are going to have a one-shot revision series in the whole month of February, in which we are going to go for some of the very important questions of grade 9 and 10. Okay, so kindly participate in the classes to experience some of the important questions of your syllabus. Okay, next is define alloy and amalgam. So if we go for alloy, what is alloy? It is a substance prepared by addition of, see, either metal to metal or metal to non-metal Okay, and what is it used for? To change the properties. Okay, so see, what are the process of alloying? Either we melt the mixture, okay, and then we mix it, or we compress it, okay, and then we solidify the mixture. So there are different methods of alloying, but basically alloy is when we are mixing a metal with another metal or with non-metal to have a change in the basic properties. Okay, I hope that is very much clear. Now let's move on to the next category or next definition, that is amalgam. So amalgam, it is alloy in which one metal, or we would say base metal, is mercury. Okay, if I talk about the amalgam of sodium, okay, so that is used to lower the reactivity. Okay, then zinc amalgam, it is used in voltaic cells. Okay, so this is what amalgam is basically used for. Alright, next question is the give reason type of questions. Aluminium vessels should not be cleaned with powder containing alkali. Okay, now if I talk about aluminium, it is amphoteric metal. Okay, that means what it would do, it would react with the alkali present in that cleaning powder. So it will react with alkali. Okay, and what it will be forming, it will be forming a soluble salt and it would corrode. So therefore we are not supposed to use the cleaning powders which have alkali to clean the aluminium vessels. Okay, because it would be reacting with those alkali, it will be forming a soluble salt and it will corrode the aluminium. Next is aluminium is more reactive than iron, but it has got less corrosion. Okay, alright, now talking about aluminium, when it reacts with oxygen, okay, it forms a layer of aluminium oxide. Okay, so this particular layer, it prevents further corrosion. Okay, and if I talk about iron, so rust, it is again falling off and the further corrosion takes place. So the basic reason for aluminium not getting so much corroded is because of this layer of aluminium oxide that is formed, which prevents the corrosion. Okay, then food containing iron salt shouldn't be cooked in aluminium vessel. Now, okay, so if I talk about aluminium, it is more reactive than iron. Okay, so that means what? It can displace iron from salt. Okay, and therefore we should not cook the food having iron salt in the aluminium vessel. Okay, so that is the basic reason. I hope that it is very much clear. Okay, so these are the I would say some of the very important questions that we have discussed in our today's class. Okay, and also students, there is one more question that you should not be missing it. It is the extraction of aluminium. Okay, so whatever steps are taking place, so you should go with that. Okay, so I'll just show you the extraction of aluminium. So you could be directly asked a question like, prepare a flow chart for extraction of aluminium, or what are the reactions taking place. Okay, so firstly, what are we having? We are having ore, that is bauxite, Al2O3.2H2O. Now this ore, it goes for concentration process. Okay, and it is done by sodium hydroxide, and we get alumina from that. Okay, so basically what is happening is we get sodium metaluminate, then sodium metaluminate, it is dissolved. So let me give you the basic reactions. Okay, just a minute. Alright, so if I go for reactions, it is dissolved. Okay, then the temperature is maintained at 150 degrees Celsius, okay, to get sodium metaluminate. Then this sodium metaluminate, it is dissolved again. Okay, and this is maintained at 50 degrees Celsius. Okay, so we get the precipitate of aluminium hydroxide. This precipitate, it is then dried, washed, filtered, okay, and then it is ignited. So this precipitate, when we ignite it at 1000 degrees Celsius, we get the alumina. Okay, now after that, it goes for the reduction of alumina. So if I talk about the electrolytic reduction, so there is a question that we already did, why we went for electrolytic reduction, because it cannot be easily reduced by carbon or carbon monoxide, etc. So for electrolytic reduction of alumina, we are using electrolyte as alumina, cryolite and fluorspar. Okay, at cathode we get aluminium, at anode we get oxygen. Okay, also the anode, it needs to be replaced from time to time. Why? Because it gets oxidized, okay, and it damages the graphite rods. Okay, so these are the things which are, or these are some of the questions which are important from your metallurgy unit. Okay, now students, you have one more chance to crack Unacademy Prodigy. The test, it is once again scheduled to happen on 27th of February. Okay, you can crack it, you can win amazing prizes. Okay, there are scholarships and prizes worth 10 crore. Okay, so the session, it is going to, or I would say test, it is going to happen on 27th February from 12 to 1 p.m. Okay, so kindly make sure that you enroll yourself right now to have this amazing chance. Okay, also students, please enroll yourself into the upcoming batches. Okay, so you can enroll yourself into the batches of grade 10 and you get the subscription of grade 11 and 12 absolutely free. Okay, now students, if you have, or if you are facing any problem about the okay, Rama Shankar Bari session PDF, you will be getting in your Telegram group. Okay, so you can join the Telegram group to get the PDF of sessions. All right. Okay, so if you're confused about your preparation journey or your subscription, or you want to know about some latest offers, you are just one call away. So you can call on this number, a counselor will get in touch with you and they will be helping you with the problem or any confusion that you have. Also, you can use my code, okay, to avail the extra discount. Okay, and please students, take the plus subscription and take your preparation journey to the next level with Unacademy Plus. Also, please subscribe to the channel and please like and share. Okay, we will be meeting in the next session, in which I will be bringing with me another important session for all the students of grade 10 ICSE. Thank you, and let's meet in the next class. Till then, keep learning, keep studying, Take care of yourself and all the very best for your preparation.